In this video, we'll see how we can leverage potential of diffusion model to build an app for cartoonification of real images. This is the sample demonstration of the app which we will build in this video. So without wasting any time, let's get started. Let's understand the flow first. We'll use stable diffusion models using automatic 1111 web UI with its API enabled. We'll set up this later in the video. For model, we'll use Pyrite V4 from Civit AI, which is a great model for generating anime characters. And at last, we'll use Gradio with Python to make a sample UI to take an image and pass it to the API. So this is the final flow. A user will upload an image, then the UI will pass the input image to automatic 1111 API to generate anime version of an image, and then return the result to UI again. Now let's start practical part by setting up automatic 1111 first. Go to github.com and search for automatic 1111. Click on stable diffusion web UI repo. This is the popular user interface that also provides API. Click on code and copy HTTPS link. Open command line and use git clone with copied link to download the source code into your PC. Once it's downloaded, get into the directory and you'll find a lot of files and folders. If you're also on Windows, then use webui user.bat, but if you are on Linux machine, then use webui user.sh. Once it's launched, it will take time to set up environment and dependencies like PyTorch, code format and all for first time. It mainly depends on your internet speed. Once it's set up with environment, it will download the base stable diffusion model. And then it will launch the UI. Now our stable diffusion UI is ready. Now we need the model which we'll use for cartoonification. For that, go to civit.ai and search for Pyrite V4. Just look at these samples. These are enough to prove that this is a great model for generating images. There are several models out there, you can try them as well. Now hit the download button to download the model. Now copy the downloaded file, go inside your stable diffusion web UI directory, go to models, stable diffusion and paste here. All the stable diffusion models will be pasted here. Go to UI and hit refresh and you will see Pyrite V4. Click on it and it will start loading into the memory. Once it's loaded, we'll test it. Let's generate an image of a woman on a street. We'll also use some negative prompt. This is just a test image, so we're not expecting a better result, just to test that whether it can generate or not. See, it's generated without error, so the test is passed. Since we have the model, I don't want to type a large number of negative prompts or keywords, so we'll use pre-trained embeddings for textual inversion. So for that, we'll use the same civit.ai website to download the negative embeddings. Go to civit.ai again and search for bad hand v4. This will help us avoid bad hands or messy fingers at the time of image generation. Click on download to download it. Second is negative hand. This is also prevent the same bad hand problem. And the third one is easy negative for overall quality of image. Copy all downloaded files and paste into embedding directory inside your stable diffusion web UI directory. Now go to your web UI, click on textual inversion here and hit refresh and see embeddings are in the list. These will get loaded automatically on some specific text in negative prompt or some specific keywords. Now we have all the models ready to generate image, but we are not going to use this UI. Instead, we'll enable API to generate images from input image and make our own UI. So let's enable API. Close the current UI by hitting Ctrl C. Edit webui user.bat and set the value of command line args to --API. This will enable the API and you can make post request or get request to make it work. Now run webui again. Once it's launched, you can use /docs just after URL to get the API documentation. There are plenty of API here, but we need image to image API, and here it's payload. Now we have the program ready to generate image from an input. We'll make an UI and then make a call to image API with an image and some more options in payload. So let's make the UI. Here's a sample UI where we will need a placeholder to get input image, a placeholder to show and download output image, radio buttons to choose that the person in image is male or female. We are doing this for sending customized prompt to model, and of course you can customize this according to your use case. We'll see this later in the code. And at last, we'll need a button that will transfer all parameters inside a payload to model. Set up a Python virtual environment. Once it's done, install Gradio for making UI and Pillow for dealing with images. Wait for the installation. Once it's installed, make a new Python file and import Gradio, image from PIL, requests for sending post request to API, base 64 for image encoding and decoding, bytes IO for file buffer. Make a function to load the image from its path. We'll use PIL image for that. Now make a function to post request to API. We'll take image path and choice from radio button. You can get the base URL from address bar of your web UI. And then go to API docs and copy the image to image API and paste just after base URL. Now open image from path as bytes and use base 64 to encode it. Stable Diffusion Web UI takes a file as base 64 decoded. That's why we are encoding it here so that we can decode it in payload. Now define payload. Put your initial or base image or input image as here as base 64 decoded. And we'll use dpm++2s akaras as sampler. Feel free to try different sampler. You may end up getting better results with others. For now we are going with this. Define width and height of generated image. Keep that in mind. For better result, this should be equivalent to input image. Now I am going to convert a portrait image to anime. But for your use case, the prompt will be different. So keep that in mind. I am writing prompt with a condition that is self-explanatory. Now in negative prompt, we'll use specific keywords that will use our textual inversion embeddings. These keywords will trigger them. Denoising strength will define how much the model should modify input image. Value close to 1 will result in completely random image and value close to 0 will less affect input image. You have to give some hit and trial for your use case to get a satisfactory value. CFG scale for making a balance between your input image and prompt. Higher number of steps will result in higher quality output but will take more time to generate. So keeping it a bit low. Now we have our basic payload ready. Use requests to make a post request on Stable Diffusion API and get the results. The image will be in JSON in base 64 decoded format. So we'll take that and use base 64 to encode it back and then use the PIL image to load. Now we have API calling part is set up. Let's make the image placeholders and buttons and the whole interface. We'll use Gradio blocks and use row to place both image and output image placeholders side by side. So make placeholder for input image or original image and one for showing output image. We'll customize it by passing parameters like it should receive an image in PIL format and make it non-interactive because we are not going to upload or modifying image from this placeholder. A show download button will be enabled so that the output image can be downloaded. Put a label and enable showing label on UI. We'll make radio button outside the row so that it appear on bottom of placeholders. And these are the choices which a user can make. Finally, we'll put a button named Tune Me to Cartoonify. Let's define the behavior of button that the clicking on button will call post image function by passing input image path and choice and set the output to output image folder. Now we can safely launch interface. Now hit run to launch. And as you can see, we have places for input image, output image, choice and a button. Click on upload icon to upload an image. Select your image and then it will show a preview here. Choose options based on input and hit the button. Error? What could go wrong? Oh, the culprit is here. In Keras, it's uppercase K. Now rerun the UI again. Choose image. Select female as the image is of a woman and hit Tune Me button. Now output placeholder is waiting for response. Meanwhile, you can see the progress in terminal. Once it's done and see, isn't it beautiful? Let's try with one more image. And wow, as expected. So this is a tutorial to make a Cartoonify or web app. Similarly, you can deploy stable diffusion UI and make a mobile app like this to convert portraits to anime. That's it for this walkthrough. I hope you liked it. If you do, share this video among your college friends who need a project. In next video, we'll know how exactly diffusion based models work. So stay tuned for that. And as always, thanks for watching.